Hello. So in this video I want to talk about assignment 6 and explain what needs to be done. The basic idea is that Dijkstra's algorithm is the basis of many route planning algorithms, route planning applications like Google Maps or Waze or things like that. And so what you're going to do is build a Dijkstra's algorithm to find the shortest path between two towns. So there are four basic classes that you'll be building. Two data elements, the town and the road. A town is basically a vertex in the graph, and a road, of course, is an edge. So the compare to method compares two road objects, and the same for the compare to method in the town. And if the names are the same, they're considered the same town and same road. Then the graph is going to be going to implement the graph interface, and it's going to have a shortest path method, which calls Dijkstra's shortest path. The shortest path finds the shortest path from a given source to a given destination. The shortest path, the Dijkstra's shortest path, finds the shortest path from the source to every other vertex in the graph. And you'll be coding that up. And then you'll be able to find connections between two towns that you'll read in. So you can use either matrix, the adjacency matrix approach, method 1 in the previous video, or method 2, the sets of towns and sets of roads. So the shortest path algorithm will use a weighted graph, which means that the weights will be the distance of the road, of each road in miles. Then you'll build a town graph manager, which implements the town graph manager interface, and this does the administration of the graph, populates the graph, adds the town and road, lists them all, and the solution finds the shortest path from a start town to a destination town. Accounts for the possibility of a disjoint graph. And there was some confusion about this in prior assignments, but you can add any method you need to complete your design. There are two exceptions that get caught: file not found exception and IO exception, and the GUI driver. These two exceptions already exist. You don't need to create them. The GUI driver is provided, and it has 4 sections, and in a few minutes I'll bring one of those up and show you. So in the testing, you have to pass the Town Graph Manager test and the graph test, and you need to build the following set of student tests and cause them to succeed. So now a few details about the assignment. There is a file. There are 2 files actually, one for Maryland towns and one for U.S. towns. It's actually the eastern part of the United States, the major towns. And 2 PowerPoint slides showing the graphs of these towns. So let me show you this is the Maryland PowerPoint slide. And one thing you'll notice right away is that if you drive 270, it's called 270 all the way, but in order to have unique names for each edge, each road, I called it I-270 North, I-270 North Central, I-270 Central, I-270 South Central, and that's the same way with many of these roads, and they connect. Each road connects 2 towns. Now, by the way, when you delete a town, you need to delete all the edges that are incident to it, just because an edge doesn't hang out there by itself. So the file will, let me bring up the file and see if I can find it. There's the file, and the GUI reads the file. It reads the name and a comma and the weight, the length in miles, then a semicolon separating the edge from the two towns. So you don't need to worry too much about the format of the file, because the graph, the GUI, reads those files in. So this is what the GUI looks like. You will read a file, and then when you can either show the towns or show the roads, and if when you read this file, these drop boxes will expand to show the largest of the towns. So when you respond to the Add Town button, that's simple. You just type a name and add it. The Add Road button, you need to, as I mentioned, it has it is required that a road be connecting two towns. So you have to select the two towns from the combo box. And then when you select the Find Connection button, after you've selected a from, to, and you select Find Connection, it'll run Dijkstra's shortest path and find the connection between the two. So if I found the connection between Bethesda and Clarksburg, I would start at the source, and you'll need to do this. You'll need to make sure it works this way. Start at the source via the road name to the first destination on the route, and so forth down the list until it gets to the last destination, to the destination Clarksburg in this case. So if you select the source and the destination and they're the same, or if there's no route between them, in other words, it's a disjoint graph, you need to state that in the text area. So there's the format, and that is basically the essence of assignment 5. So feel free to email me with questions if you have questions about assignment 5.